From the solar winds to the mystical auroras, science is a way of knowing, a way to help us understand the world around us. But how do we learn about the things we see, and how do we make sense of the things we don't understand? Find out next on Real World. As humans, we're all really curious about the world around us. Science is a way of knowing, but what does science really look like? Let's drop in on some NASA researchers who are currently working from home. Dr. Nicolene Weil studies the sun and solar winds by analyzing data from spacecraft, like NASA's Solar Dynamics Observatory. Dr. Marilia Samara studies charged particles in space by sending rockets into the auroras. And Amber Versteinen is an undergraduate student majoring in atmospheric science. Amber's internship at NASA helped put her on the path to a career in science. Dr. Weil, can you help us learn more about the nature of science?
Science is about understanding the natural world around us. Science is about finding new information, which inherently comes with being wrong a lot of the time. By definition, you're exploring space and questions that nobody has really thought through before.
Dr. Samara, how do these questions drive the study of science?
We'll ask questions, we try and figure out what experiment might help us answer those questions. We go for it. Usually we don't figure out enough, we try again. We had no idea how the aurora was created, but people would notice that when they had a compass and there was aurora going on, funny things would happen. So they knew it had something to do with the magnetic field.
Scientists use different methods and tools to gather a variety of mathematical data. Data may include images, numbers, patterns, shapes, and calculations that help model and describe the world around us.
So think of images just with like a camera. That's a remote data set. You can do it in optical light, the light that we can see with our eye, just like with a regular camera. But we can also look at the sun in other wavelengths, other types of light, like X-ray light, ultraviolet light, infrared light. And so those are give you other types of information about the sun. The other type of information that we can get is called in situ, and that means measuring directly where you are.
In the case of aurora, we're trying to launch and go over the aurora in what we call the apogee, which is the highest point from the ground, and make measurements there. By concentrating on the apogee, we effectively get a snapshot of how the environment, that space plasma environment, looks at that particular time, at that particular altitude. It's surprising how much science is in just a couple of minutes of these measurements.
When we look at data for a long enough period of time, we can understand patterns in those data and really make sure we're not just answering one little question about the sun, but that we're really pulling all of the information together and making sure the big picture still makes sense of how we think the sun works. When good science is being done, it leaves room for us to change our mind, to realize we were wrong about how something was working as we get new information, and we have to refine our ideas about how the natural world is working.
Scientists do their best to understand observations with the knowledge and tools they have, but sometimes scientific explanations change.
So I think of science as basically a puzzle. We have tiny pieces of the big puzzle. Every time we have a new piece that actually connects, our image changes.
We do our best to describe what we see and what we're observing, and then we figure out which parts still aren't making sense. Sometimes a model will make sense and explain all of the observations that we have today, and then tomorrow the sun will do something totally different and we'll have new observations. And it's not even necessarily that the model was wrong, it's just that the model was incomplete.
It's important for all of us to understand the nature of science because we can all be scientists, asking questions and gathering data. Amber, you've had a chance to collect data during your internship at NASA. What were you studying?
While I was in high school, my first project was studying ozone and how it affected plants by working on an ozone garden that was at the Virginia Living Museum. An ozone garden is a garden that consists of different types of plants, some that react to ozone and some that don't. So some of the tools we used was a meter stick to measure the heights of the plants. We used a rain gauge to measure how much rain all of the plants were getting. We used a thermometer to measure the air temperature that the plants were growing in, and we used a psychrometer to measure the relative humidity of the garden each day. The ozone garden research was really important because it shows how different plants grow more efficiently in different climates and how ozone has such a big effect on plant growth. This is really important to understand with our changing climate.
A new fact is really like a new piece in a science puzzle. As more pieces are added, the big picture becomes clearer and clearer. But it's important not to try to force any pieces that don't fit.
It's important when we do science to do our best to overcome our biases. Everybody has biases. It's important to be ready to be proved wrong.
Science is a human endeavor, and our understanding of science is constantly changing. Men and women from all cultures and backgrounds choose careers as scientists and work in teams to answer the questions we have about the world around us. So, how can you get involved?
So don't just sit there. Ask a question. Make an observation. Use all the tools you have to collect evidence. Even do a citizen science project. You could even do an internship, maybe even at NASA.
So what are you waiting for? Science is an amazing way to use math to help uncover grand mysteries in the natural and material world. Special thanks to Dr. Nicolene Weil and Dr. Marilia Samra for helping us understand more about the nature of science. And thank you, Amber, for helping us see ourselves as scientists. I'm Sarah, and see you next time on Real World.